Hi, everybody. I'm Gianna Cothran. Let's see, I need to share my screen first. Okay, can everybody see? Yes, okay. All right, so David and I have been working this summer on our module with rational method to PCSWM and coming up with the different methods there. So basically, we have our introduction here that's looking at a variety of different runoff models, starting with the most simplistic, like hand calculation and spreadsheet type calculation, simplistic models, moving on into computer simulations with PCSWM. And so the idea is to have students learn how to go through each of the different methods that we present among the many other that are available out there, and then be able to make decisions on what are the best models to use for certain situations, because sometimes it's not always appropriate to use the biggest, best, and most powerful when you can do something fairly simplistic. So you'll notice in our section here, the little intro target audience is for a hydrology junior, senior level type class. So prerequisite materials for those types of classes would be needed to be able to get through the material. As far as tools needed, generally being a Word document for submitting things and also spreadsheets. But most importantly, the PCSWM software, which is available to universities. You can get a license package for teaching purposes there, so that's listed. And in our module, you will be able to access the information that you can open with the PCSWM there. Okay, so let me go ahead and click on the preview tab. I've been a little nervous about using my preview tab here instead of the outline tab, but I'm going to go for it. Okay. Our overall learning objectives are listed here. So basically, we will start with the rational method, then take students on through curve number calculations, and go to a SCS triangular unit hydrograph method. Those are our more simplistic types of methods, and explain the uses for those. And then at the point after I explain those, David is going to take you through the PCSWM model and what the students will be learning in that section. And then from there, it kind of culminates with actually looking at different projects and selecting. The student goes through and selects which model is appropriate for a specific application that's listed. So we have those set up with learning objectives, and each thing is mapped out to each one of our units here. Okay, so as far as the site information goes, I am from near New Orleans, Louisiana, and this is a common sign you might see. Actually, this is in my neighborhood. Back in May, we received 12 inches of rainfall in just over 2 hours. And that is a near 500-year event here. And so obviously, near New Orleans, our area makes a good site for any kind of urban drainage type studies for stormwater analyses. So what we have here is our specific site, which we try to thread throughout the whole course, throughout the whole module as you go through it. There is the Gentilly Resilience District. That's a place that's in New Orleans where they have set up or basically are in development of various projects for that area, where they are really trying to get a lot of community engagement for the community to participate in becoming more resilient to these high flashy types of storage or storm events that we get. So the student can read through some of that information. But in addition to that, what I want you to see, so this is the site information. It's just sort of an intro right here. What we did is we put at the top, and that's listed in here, right here at the bottom, that throughout the module, the student can refer to what we call the Green Streets project page for any details about the site that they want or need for any of the learning activities. So we incorporated that here in the site page. It's called Green Streets Projects. So this is a typical New Orleans flooded street. And it can get much higher than this. This is just when you're able to actually get out and take the picture, right? On Gentilly, there's a couple of streets that are, I'll bring up this PDF. There's a couple of streets in this neighborhood, this is the graphic, that are being completely reconstructed, this Wingate and, Wingate and Willdare Drive. And there's 3 sections that one of the design firms is currently developing now, or designing for now, the south, middle, and north section. So David and I selected this south section that we have listed here on our site, okay? And the design firm that is currently developing this area, this is called the Gato Playground or Park, and they're looking to install these bio-retention swales. I think it's 4, I believe there's 4 of these large systems along the outer boundaries of the park. And then around here, this is just the graphic of the park, but also around here, you have all of the residential neighborhood that exists. So this is the site and what the current design firm is up to. In addition to that, they're also doing bio-retention along the streets, along the edges of the streets. And some changes are made in the construction of the streets themselves. And then not in this playground, but in one of the other parks of like I think the middle section and maybe the north section, they're putting in even larger detention types of facilities. We didn't do that for our site project, but where they're putting the underground large storage tanks for detention. But this is our site. This is one of the My Maps David created that you can click on it and you can go in and get to the detail. He's going to be working with this a lot and showing this to you. So you can go in and pick out information. You can go and measure any of the areas that you need to for that. And then we also have the drainage pipes. So this right here, this is the street Willdare and Wickfield that we're going to look at, and the students have access. This is from the Sewage and Water Board in New Orleans. They can look at the pipes and the flows and the sizes. Not a whole lot of survey and pipe invert elevation on here, but there's some information that's available to the students on that as well. Let me try to get myself back where I was. Am I still in preview? Okay. Okay, so that's about the site. Then next, the next session actually begins what I have here on the learning objectives for the calculations for the rational method. And we have that listed out with the outcomes that are expected. And I'm just going to kind of go quickly through some of this. We go through the rational method and how a student would be expected to perform that. And there's an example spreadsheet that's available for the students, how to come up with their curve numbers. We tried to provide all of the resources. If they click here, they can actually go to put in the Gato playground information here and get their point precipitation data. It explains about the time of concentration and calculating those sorts of things. So, and then I do have a rational method example for them to follow. I guess that's going to pop up on the wrong screen here. Okay, well, there's a spreadsheet. Yeah, I'm not going to go through it, but to be popping up on my second screen. So. students are provided with an example such that, and they'll use this example when they go to do their assignment. And then next, we go into just a quick checkbox, quickly checking the understanding after looking at the rational method example, and then they move into their example or learning activity. So for the learning activity, it's set up, again, it's supposed to be an authentic task. So here, what the students do, we have the proposed site that's already given in the tab above, but they're asked, they're told that they have an overview presentation at an upcoming community engagement event, and for their presentation, they have to prepare for questions that might arise from the participants that might be interested in knowing the amount of runoff that their existing drainage system can handle. And so we give them some specifics on, it's got to be a 2 to 5 year storm that they are going to calculate this for. And then ultimately they want to be able to discuss with the participants whether or not the current size pipes that are there on the existing street are adequate for this specific return period. And so we go through with the instructions on how to do that. And of course, the spreadsheet example is what they would use as well. And they can use the site location and get some of the information from there. Other details are just provided through the tables that are given earlier. And then there's a couple of summary questions and a rubric that goes along with this particular activity. So the students will be turning in a one-page sketch and some hand calculations or spreadsheet calculations with all their assumptions made for this quick and easy, simple calculation. And then after that, there's a little piece just on calculating the existing capacity and whether or not they're sized properly, and we have an open response that's available for them at that point where you can just get some feedback, get some discussion going on that particular exercise. The next section then is all about the curve number and the unit hydrograph. So this is a little bit of background information that's provided on unit hydrograph theory and what to do with a unit hydrograph once you have one by developing basically the direct runoff hydrograph. So that information is provided there, and there's a little discussion piece here for some questions that have been provided for the students. We do refer to some other methods that are in HydroLearn. They're not necessarily needed to complete these exercises, but for the student that's interested, there's other modules, many other modules that would benefit them if they took the time to.
I'm going to be coming in Pittsburgh now in a few minutes.
Let's see, get down to the end of this. And this is the development or the background information on the SCS Curve Number method. And then I have some links to some more spreadsheets here that they can look at how to do these calculations. The data there, the curve number tables are available. And then I borrowed Peter Rogers' video, an excellent video on explaining how to get that effective precipitation, and then the little assignment on calculating your own precipitation. Also have a little segment here on finding the averaged curve number. And let's see, I just want to kind of go quickly through this. It's kind of a lot of equations, I know, but these are all developed here such that the student can pretty much follow them. If they put them into their spreadsheet, then they will be able to solve for their peak flow. And again, I'm not going to click on this because it takes it a little while. It tends to open it, but I have the example problem sample for them with the SCS triangular unit hydrograph method. And then in addition to that, I have a little video, and I'm not going to play the video. You can look at that if you have interest later, but I created a video that takes them through the method of convolution once you've developed. So first you develop the unit hydrograph, and it takes them through the method of convolution for coming up with their direct runoff hydrograph. So, which will then lead them, after a quick check your Oops, I guess that there is one that's just a template so far. It should lead, yeah, here we go, to the learning activity, the second learning activity here. And so this one is on calculating the site runoff with the unit hydrograph method for SCS. And they will go through that exercise. And of course, we have with the exercise some additional questions and our rubric for grading that. And it is all tied back to the original objectives as well. And then the next section basically is more of a introduction for what's coming next when we get to the PCSWM part. So it talks a little bit about coming up or a little bit of background information on detention and retention and routing, but we really don't get into the details of this. Just mostly because of the level of the class. This is probably a little bit more. I mean, I do one calculation in my class, but it's basically showing what routing is about and why you need it and what you're looking for and how to come up, like where would the volume be for design and that kind of thing. But we don't have a specific learning activity for this one. It's just that the students need to have that understanding of information when they start to learn about how you might use the low impact development systems to handle some of the volume, to store and delay some of that volume for storm systems. So that leads us into a section on different types of LIDs, and we don't really do an overview of low impact development systems. We just mention a couple that are actually going to be used in our PCSWM model, just to give an introduction to them at this point before they learn how to enter that into PCSWM. So they know, basically have a picture and a mental idea of what they're going to be working with. So this is just an example of bioretention swale. And then we have a vegetative swale here. Okay, that graphic changed. I don't know what happened, but that's supposed to be a bioretention cell that's right there. And then some pervious pavement, some information. And then there's just this short sort of essay assignment or an email assignment where they're asked to, after the last engagement event for the learning activity, the students are asked to send a follow-up email to one of the participants that had a question about something he talked about at the engagement event. And so the students asked to go in and calculate using his SCS method the volume under the hydrograph for a particular event, and then compare that to the volume that is currently proposed by the systems, the bioretention swales that are currently being designed. And so they would put that into post, this discussion forum post. And then that should bring us to the part where students will start learning about PCSWM, and David's going to take over from here. So I'll click the stop share. And David?
All right. Hello, everyone. I have a 1-week-old in the background who's screaming this song over people. So if you hear that, I apologize. So now that Gianna has gone over the intro and the simplistic methods that we use here in this module, the module then goes into PCSWM. And I know we're kind of running out of time here, so I'll give a brief overview. Effectively, the section 2 of this module takes students through, or guide students through, the full construction of a PCSWM model. That includes a PCSWM theory section, and in that section I go over how subcatchments are modeled in PCSWM. There's an example where an Excel solution is made for one subcatchment, and students have to go in there and tweak some parameters and see how things work. Then the module essentially guides students through the step-by-step process of creating a module. So they have to go into the maps, the satellite view, the drainage network for the Gentilly site, and add in all of the drainage network underground. We're providing them a digital elevation model, so high resolution LiDAR data that they can open up in the GIS capabilities in PCSWM to determine things like subcatchment slopes. Put a lot of emphasis on determining how many subcatchments to divide the site into for a reasonable balance between accuracy and the amount of time taken to set up the model. But effectively, this is a really comprehensive and thorough guide for students on how to set up a PCSWM model to obtain an outflow hydrograph, as well as to assess things like flooding conditions on the streets inside of this site. At the end of that, we also, just like we had them analyze some LIDs in the curve number method, we have them include the proposed LIDs in PCSWM and just analyze their effectiveness. So for a given storm event, how effective are the proposed LIDs at reducing runoff and preventing flooding and things like that. After the PCSWM section, just to wrap up, the culminating experience at the end, now that students have experience with these three very different levels of runoff models, we ask them to compare them, to reflect on their experiences there, and then we throw them into 5 different scenarios inside of here. Let me pull that up. Apologize, one second. We throw them into 5 different scenarios, and we ask students to select a runoff model that is appropriate for that given scenario. So we provide students with all the relevant considerations for how to match a model to a situation. So what results do you get from a runoff model? What results do you need in the particular analysis you're doing? What are the limitations of that model? And understanding that time is money, that they should usually pick the simplest model for that meets the criteria for the situation. We go into some of the considerations of input data requirements. Increased complexity usually means increased cost of data input. And then also what agencies are requiring. At that point, the culminating learning activity is effectively a set of reports that the student has to create. So we have a results template in here, and effectively we're throwing the students into these scenarios. So we give them, we throw them into this scenario and ask them to select a runoff model that they would use. So they select, for example, in this one, they might say a rational method approach is the most rational method, let's say. And we ask them to justify that conclusion. So we ask them to describe how they're going to apply the model, what results they get from it, how do those results support the end goals of the project, and why is the selected model the best balance of all the relevant considerations. So there's 5 different situations that we throw students into at the end here to round this out. And we wanted to, in this module overall, introduce students to these different runoff methods, but crucially have them be able to know when to use each one of them. So that was a lot of the idea behind this, was to not just show them each of these as individual chunks, but to have them put it all together and see how an engineer would actually choose which one of these to use in a given situation. And I think we're out of time, so I'll stop there.
All right, thanks David and Gianna for sharing your module. In the interest of time, we'll go ahead and take just one question or piece of feedback for David and Gianna's team. So if you have a question or feedback, I think some feedback Joanne posted in the chat. But if anyone else wants to jump in, you can unmute yourselves or post in the chat.
Hey, I had a question. Awesome job, you guys. Looks like you put together a lot of material for students, and congratulations. I heard you had a 1-week-old, so that's awesome. My question was on the matching models or matching the situations. Are there sometimes multiple answers to that, and how are you going to assess that?
So the answer is definitely yes. I mean, there's definitely not one correct answer to most of the questions. Certainly some of the really simple ones, there might be one correct answer, but it really comes down to the rubric in grading that. So we ask them to select the model, describe how they're going to use it, and then justify or discuss why the level of complexity that they selected is the most appropriate or best choice for the job. And really, I mean, what we're assessing is not their selection, but how they discuss that. So whether they're mentioning the relevant considerations and talking about it in a meaningful way. It's a good question. So yeah, so it's pretty open-ended.
Thanks, David. I look forward to checking it out.